Grüezi YouTubers, here is the guy with the Swiss accent.
This is what I got from one of my viewers. 2 packets, 2 antennas, 868 MHz, a distance sensor, a PIR sensor, and 2, what I think, battery holders. So what's in here? Let's check. This is a nice small PCB with a Atmega chip on it, the 328P, and this is nothing special, but on this side we have an RF module. This is a RF module which is able to communicate over the 868 MHz. It's called Whisper Node, and it was a Kickstarter project. And I got these 2 Whisper Nodes to do what I want with it, and I have some plans. First, I want to understand how they work, or if they work. That is number 1. And number 2 is to use it maybe in a reasonable setup. And number 3 is I also would like to compare their reach with my LoRa stuff I have built over the last few weeks, because they work on the same frequency band. So I'm very interested also their long-range capabilities. They claim to go. They claim a range of a few kilometers or miles, and this is what they have to prove, I think. But first, I have no clue, and I have to start. From what I learned is they are somehow Arduino compatible, and now I have to understand how to program them, and maybe we'll find a test program or something to check them out. Now, one thing is important. If I look for the second one, it's here, it's the same. Now I could try to build a communication right away, but this is not what I will do. I will first start to understand one and check then if it works, and also if we see some signals in the air, and if we know that this one works, then we start with the second one. This is how I deal with problems. Always reduce complexity at the beginning, reduce the number of, as I call, moving parts, because if you have 2 moving parts, the chance to find out what is right or wrong is much smaller. So I start first to understand this one. And by the way, it's an Australian product. It's .com.au, and the version is 0.3, which is interesting. The version numbering is anyway interesting. I would never sell something before the version 1.0, and I have no clue why they name it 0.3, because the self-esteem of these guys is not big if they do not think that they are able to produce at least a 1.0 version. I mean, it's anyway, it's artificial which version number you use, but with a little bit of self-esteem, I think you could say, if we produce it, if we sell it, if our customers give us money, at least we should be quite sure that this is version 1.0. But anyway, we'll see if it is 1.0 or 0.3. So if we start to look at the board layout, this is basically their repository. The board layout looks similar than what we had. And here we have the FTDI connector, and I assume this can be used to program, but of course I would like to understand if we have also serial to USB converter or a USB to serial converter, and because then it's easier to program the whole stuff. Program interfaces, the ICSP and an FTDI. Search for USB. So you see this USB is not connected as a USB, so we have to use the FTDI to program this thing here. So I think I have to do some soldering.
Fortunately, they supplied these header pins, and they always put some flux to make soldering a little bit easier. And flux is sometimes dried in, so I need a little bit of alcohol. Now it works. Just a little bit of flux helps a lot in soldering afterwards. Looks good. So that's okay, number one, and we stick with this number one. Now we can program the whole stuff. I have my FTDI converters and I have a USB connection here, even if my computer is not on this side of the table. And I have now to connect it to 3.3 volt, which is already here. Then ground, RxTX, and with the son-offs, I used this for the son-off last time. I didn't need the VCC, but now we need also VCC. And you see also here, VCC is red, ground is brown or black or blue or something, that I do not mix them up. Now I unplug it first and then I try to understand, and now these, they are here. So ground is here. I think I switch off the loud noise here. So I just usually quickly check with a ohm meter, because a second check with a different meter is always good. And the most important thing is ground, and I assume ground is here, and I assume ground is here, and the next is VCC. So this is already one interesting thing. And you see, I didn't power the whole thing up because I first want to understand what I do, because otherwise I fried already a few boards, and these are quite valuable boards. One is about $25, so I have no interest in frying one of these. Okay, and now if we deal with RF, we always have to put the antenna on before we switch on, because we do not know what code or what program is on this Arduino, and maybe it starts to send immediately, and this would be no good thing if there is no antenna. If there is no antenna on output, only on senders, not on receivers, then basically the whole energy cannot go out. So it is reflected 100% back to the last parts of this IC here. And this one heats up. And if you are unlucky, then you fry this whole chip here. So never forget the antenna if you deal with RF devices. You might be lucky and nothing happens. Depends really on the design here and also on the power, which is the output power which is provided by this chip. Okay, and now we should be able to power it up. Check again the 3.3 volt. Measure twice, cut once. This is what my father told me once. And I did not always follow. So something happens. Now we know this is on 868 megahertz, so we can start the spectrum analyzer and maybe we already find some signal in the air. So far I don't see anything, so maybe this sketch does not send anything. For the moment I do not see anything in the band of 868, so I assume the sketch does not send, but at least it blinks somehow.
So we see here that we can use the library manager to install the library. So let's try. Sketch, include library. I assume it's Whisper. Yes, it is. Install. Close. Now usually we have to select a Arduino Mini or Pro Mini, and then we can search for examples. Basic, blink non-blocking. Okay, so let's start with the easy one. We see the speed of the serial and upload it, because obviously there is a bootloader. So we need the RF69 library. So again, include library. I don't find anything, so I have to check on their website. There is nothing here. Maybe there is a remark in the code itself. No hint to the library here. So I think I try to RF69. I don't find anything. Nothing here. So we have here the name of the library file. So we've searched for this one here. Maybe we find it. Aha, Radiohead. RH Radiohead. It's here somewhere. So I assume we just download the zip file. So we have it here, and now we try it again. At least it takes a little bit longer. So it does not want to upload. Oh, here we have a include library, talk to, yes, this is what we did. Low power. But now the next thing is really how to install the whole thing. and how to upload the whole thing. Aha! Now we have also to install Boards Manager. So it needs also a new Boards Manager. And this is easy done. File Preferences. And we just add here at the end. We add with a comma. We add this new JSON file. Okay. And I think we have to restart. Here we have it. Install, close, and now we should have them here somewhere. Yes, here we have it. So we have this Whisper node. And now we try again to upload. Same thing. Anything else to? Default. COM10. Because COM5 was another ESP board, and of course the ESP does not. But still not. So now I don't see anything else. But now I see some interesting things here. I see that we have some signals. Interesting signals, completely different to the LoRa signals. At 868, more or less. This is 868. This is 868.5. So it's around 868.100. 868.125. It's another day in the morning, and I had yesterday evening a chat with Thomas, the guy who gave me these Whisper nodes, and together we found out that I made a beginner's mistake. I forgot to connect the DTR pin. Usually if I program with this serial cables, I never need the DTR because I don't use a bootloader. Now with a bootloader you need obviously the DTR to signal the bootloader that you want to upload. So also here some beginner's mistakes. Now everything works, and usually if I work with these boards I have to program them quite often. That is why I use a connector cable, and I use empty shells. And then I manufacture a small cable which fits exactly the pins here and the pins here. Then I don't do any mistakes, and I can quickly connect and disconnect the cable without making errors and mixing up, for example, VCC and ground or stuff like that. With some tweezers from Heiko, this is done easily, and so I have now a dedicated cable to program this. And obviously VCC is okay, everything seems to be okay, and we can try to program. I save these small pins here because I will destroy this cable probably later on, because if I don't need it anymore, I just remodel it to the old state, and then I can reuse these empty shells and I can reuse the cable for the next project. Or if I want to keep it, I label it here with FTDI and here with Whisper node, and then I have a dedicated cable also for the future. Now we can go on with the second example. This one is already with communication, because we know obviously we can upload. We saw also that the transceiver worked, and then we can try to communicate
with the other one. So I chose the voltage example. So for example, if you work with a battery, you can check the battery voltage, and if the battery is low, you can send a help message to the administration that the administrator maybe changes the battery or something like that. So that is okay. And now let's upload this one. So at least there is something here. But of course, because I have no other station, only one station, we cannot read anything. So I printed two labels. One is base, the other one is node. So this one is the base, and we label it base. And the other one will be the node. Okay, so this is the node. And now we see already the advantage of this plug here. I just take it here. Oh, I have to solder again. But I will not show you how I do it. So now this is also soldered. So we have the node here. And now we just have to pay attention where the ground is. And this is why I put a small sticker on this side towards the antenna. And now it's even easier not to do some mistakes. So I can now program it as a node. So let's program the node. And here we have the node. And now I connect this one here with USB. Like this here. So the node should send a signal now, and the base should receive it. And the power supply has 5300 millivolt. I have no battery attached, so it's 5.3 volt. Maybe we check. .25, which is reasonably exact, because the Arduinos do not have a very precise ADC. So now we have a communication between these two nodes. Great. So this was quite simple, I have to admit. Once the problem was solved with the libraries and everything as usual, the whole thing works quite fine. Okay, and now we check frequency. Start frequency 868, stop frequency 869. And I don't see anything. So they probably choose a different channel. The other possibility is also of course to go to the code and check the frequency they selected, because obviously the communication is very fast, so the spectrum analyzer might not get it. The frequency is 916, which is not very legal here. Fortunately, I'm in the basement.
So I think I change the frequency to 868 because anyway the antenna is not very good for 915, and I think also the RF module is not trimmed to 915. And now I have to reprogram first the base. The base is programmed. Now let's program the base. By the way, never use two different VCCs. Maybe they did some protection here, I don't know, I don't care, I just don't do it. So the node, done uploading. So back to and you see now the advantage of such a small connector. And now let's check frequency. And we see here, right on the spot, we have here the signal, 868.2, but there are different peaks here. Reading the same voltage. Good. Now we have still a few questions open. The first is, for example, how far does this whisper node work on line of sight and without line of sight? Because I have something in mind with this whisper node, because I have to walk about 50 meters to my mailbox. This whisper node could be an interesting thing to use for this use case, that I would put in a read contact into the mailbox, and then I can check if the postman was already here, because here it doesn't ring twice here in Switzerland. It's only in the US. And then I want also to check how LoRa reacts if a sender is on the same frequency. I think this is also an interesting thing. So we have a few questions open, and then of course I will take my car and will make a journey and will check a few kilometers or a few miles away. I will take with me a whisper node and I will take with me a LoRa node, and then we will check out how they work. But this is definitely stuff for a next video. I hope this video was useful or at least interesting for you. If true, then like. Bye.